Welcome all to Anudeep YourStudyBuddy. Today we are going to continue with the topic called matrices. We are going to discuss about what is the application of matrices. So today we will discuss about the method of inversion and method of reduction. So let us proceed with few basics.
Method of inversion. From the name of this method, you can guess that we have going to use the inverse of a matrix. So you will be given the equation, three simultaneous equations will be given to you. You need to write this equation in the form of coefficient matrix, variable matrix and the constant matrix, so that the equation can be represented in the form of Ax equals to B. And then by using the formula x is equal to A inverse of B, we can get the required solution.
Now let us solve this problem. We have been asked to solve the following equations by inversion method. So using the matrices inversion method, we are going to simplify the equation. When we want to get the solution for the equation means we need to identify what will be the values of x, y and z. So that is what is our job. So here to proceed, we need to follow certain steps. First of all, we have to convert the given equation into coefficient matrix, variable matrix and constant matrix. Now the meaning of coefficient matrix is number in front of the variable. So as you can see, for the first equation, number in front of x is 1, in front of y is -1 and for z it is 1. It will be 1, -1, 1. Similarly, for the second equation, it will be 2, 1, -3 and for the third it is 1, 1, 1. That is what is a coefficient matrix. Variables means what are the variables involved. So x, y and z. These are the variables involved. And the constant is nothing but the right hand side of the equation, that is 4, 0 and 2. So first step is to identify the values of these three matrices and then we have to use the formula. And the formula is x is equal to A inverse of B, where A inverse of a matrix can be obtained by adjoint method or elementary row or column transformation. So we have already discussed about these two methods in earlier videos. If you have not seen them, I have given the link in the description box. You can check out those videos first and then you can proceed with the problem. So now there are only two steps. First, to get the given equation into the three required matrices and then to find out the value of x, that is the solution of the equation by the formula x is equal to A inverse of B. So let us proceed. We are going to make use of the adjoint method to solve this problem. We have identified what is a coefficient matrix, variable matrix and constant matrix. Let us assign them the names. Let me call it as a matrix A as a coefficient matrix, matrix X as a variable matrix and B as a right hand side or constant matrix. So now we need to evaluate what is the A inverse and for that matter we will be using the adjoint method. So you know what is the formula. If I want to obtain the A inverse by adjoint method, it is 1 upon determinant of A into adjoint of A. So this is the formula I'll be using. That is the first step and then we'll proceed to find out the solution for the given equation. So like you know, first will be, we have to check if the determinant of A is not equal to 0 and using the coefficient matrix to find the elements in the coefficient matrix, we'll be using the formula as discussed earlier. And once you obtain the values of coefficient matrix, we take the transpose. So now let us proceed to find the inverse of the matrix A. So the first step is to check if the given matrix is non-singular. So evaluate determinant of A and when we figure it out, it comes out to be 10, which is not equal to 0, which implies A is non-singular. So that is a very first step to find the inverse of a matrix. Then we need to find out the elements in the cofactor matrix, right? So it is a cofactor matrix for which we are finding out the elements. And the formula we have already discussed and the method you already know. So this is how we have obtained the cofactor matrix. Now the adjoint of A is transpose of a cofactor matrix. So let us interchange row and column. So it will be 4, -5, 1, 2, 0, -2, 2, 5, 3. Now by using the formula for A inverse, it is 1 upon determinant of A into adjoint of A. So what we get is 1 upon determinant of A. This is what is the value we have obtained, that is 10. And adjoint of A, just now we have obtained. So this is what is the first step. Now let us proceed with the second step. Here we will simply substitute the values of A inverse that we have obtained. That is, it is equal to 1 upon 10. And then the matrix 4, 2, 2, -5, 0, 5, 1, -2, 3. And the matrix B. B is 4, 0, 2. As you know, these two matrices we have to multiply. The dimension of the first matrix is 3 by 3 and the second is 3 by 1. So the resultant matrix will be 3 by 1. So as we have already discussed in my earlier video, we have discussed about the multiplication of matrices. If you have not seen that video, I have shared the link in the description box. So just check it out. So when you multiply, what we get? After multiplication, that is 16 plus 4, that is 20, -20 and 4 plus 6 is 10. So when we divide this by 10. So resultant matrix will be, it will be 2 minus 2, 1. And now, as you can guess, these are nothing but they are corresponding to the variable matrix. We get the value of x is equal to 2, value of y is equal to minus 2, and z is equal to 1. So x is equal to 2, y equals to minus 2, and z is equal to 1 is the solution by inversion method.
Now let us understand the second method, method of reduction. In this method, as you can guess from the name, we are going to reduce the matrix. So here again, we'll be rewriting the given simultaneous equation in the form of coefficient matrix, variable matrix, and constant matrix, so that the given expressions can be rewritten in the form of a matrices as Ax equals to B. Here, we reduce the matrix A by doing certain row transformation, and we will reduce the elements in the matrix and convert it into lower triangular or upper diagonal matrix. And then we will rewrite the equation using the reduced matrix. Then we'll be able to find the values of x, y, z. It becomes very simple to get the solution.
Now let us solve the second problem by the method of reduction. So you have been given the equation. The question is solve the following equations by the reduction method. Again, we have to solve the equations means to get the values of variable x, y, z for the three simultaneous equations. So the steps to solve using the reduction method is you have to reduce the given matrix. First of all, you have to identify what is a coefficient matrix. Once you have the coefficient matrix, you have to reduce that matrix by converting the lower triangular elements equal to 0. So using the elementary row transformation method, we can reduce the elements at the lower triangular position. If this is a matrix, this is for the lower triangular position. So this element A21, A31, and A32. These three elements, we will be making them 0, and then we will be rewriting the equations. So directly we will be getting the value of z. We will be getting two values, variables x plus y equal to something, and then in all three variables, we'll be getting the third equation. So it becomes, the job becomes so simplified when we make use of this reduction method. So let us proceed. So now we can rewrite the given equation in terms of the coefficient matrix, variable matrix as follows. It will be 1, 3, 3, 1, 4, 4, 1, 3, 4. This is the coefficient matrix, number in front of the variable. And then we have three variables x, y, z, and the right hand side is a constant matrix. This is what we can rewrite this equation in this form. So now, when we want to reduce this matrix A, this is our matrix A. So let us reduce this by doing some elementary row transformation. So our focus is to reduce these three elements, right? Lower triangular matrix element, we want to make them equal to 0. So here, I can make use of the transformation. I can change this 1 as 0. That is, by the transformation R2 changes to R2 minus R1. This 1 will reduce to 0. Then for the reduction for R3, what we can write, it is R3 changes to R3 minus R1. So let us see what R2 minus R1 and R3 minus R1, 1 remains constant. So all the elements in one R1 row is same. Now for this operation, what we have to do, 1 minus 1 equals to 0, 4 minus 3 is 1, 4 minus 3 is 1. For R3, it will be 1 minus 1, 0, 3 minus 3, 0, and 4 minus 3 equal to 1. So this is what we get. Similarly, on the right hand side also, we have to perform this operation. So 12 remains as it is. Then R2 minus R2, that is 15 minus 12 is 3. And R3 minus R1, that is 13 minus 12 is 1. Now we can rewrite the equation. What we get is x plus 3y plus 3z is equal to 12. X, it is y, plus z is equal to 3. And z is equal to 1. So if I substitute this value in the equation, what I get is 1 plus y equals to 3. Therefore, y is equal to 2. And finally, if I substitute these two values in the equation 1, x will become x plus 3 into 2 plus 3 into 1 equals to 12. So x is equal to, that is 3. So this is what is the final answer. By reduction method, we obtained the solution for the given equation is x is equal to 3, y equals to 2, and z is equal to 1. So this is how we are going to simplify the problem on matrices. It is very much easy to attempt the problem, and it is very scoring. You will be getting at least 8-mark question in your final board exam. So practice these problems well. I have also shared the different links in the description box for the various lectures that we have conducted so far. So stay tuned for the upcoming lecture on that new topic. See you very soon. Thank you.